Hello, my friends, and welcome to this quick revision in your favorite subject, chemistry. Today, we are going to finish talking about the monoatomic ions, answering the following questions. Before I answer these questions, allow me to give you a quick revision for the things we have taken so far about the same topic. Well, we started defining the ion and we said that an ion could be one atom or a group of atoms that refuse to be ionically separated from one another and it has a charge. And we said that an ion could be a cation or a positively charged ion or could be an anion, which is a negatively charged ion. Then, in the terms of the number of atoms inside the ion, we said that we have two types of ions. We have the monoatomic ions, and a monoatomic ion is an ion that is made up of one atom only, whether it is cation or an anion, while a polyatomic ion is made up of more than one atom, making a group that refused to be separated ionically, as we said before. Then we started talking about the monoatomic cations, and we said that a monoatomic cation is one atom that has lost one electron or more. And my friends, we said that the number of electrons any cation could lose depends on the electronic configuration, specifically depends on the number of electrons in the last shell or the valence shell in the atom's electronic shells or energy levels. And we said that atoms like sodium, potassium, lithium, sodium, potassium, rubidium, cesium, francium, those atoms have only one electron in the last shell, so they have two options. The first one is to gain 7 electrons, which is practically impossible because they need very high energy to do that. And the other option was to lose 1 electron so that the valence shell is going to be a new shell, which was the one before, and it is full. Then the atom is going to be positively charged with +1. Then we said that the group containing calcium, magnesium, beryllium, and the others, each atom has 2 electrons in the valence shell, and the atom has also two options. The first one is to gain 6 electrons to make the last shell or the valence shell full, which is practically impossible due to the high energy required for this procedure. Or the other option is to lose 2 electrons so that the last shell is going to be full after losing them, which is the easier and the better option. For the aluminum has 3 electrons in the last shell or the valence shell, and again it prefers to lose these 3 electrons than gaining 5 electrons to make the last shell full with 8 electrons. And then, my friend, we concentrated on a point that all of these atoms give up their electrons in order to have their last shell full with 8 electrons to gain the electronic configuration of the nearest noble element. Now, my friend, we have the questions here to be answered. Here the question said, some elements are confusing, like copper, which could lose 1 electron to become positively charged with +1, or it could lose 2 electrons, so that's going to have +2 charge. Another one is iron. Iron could lose also 2 electrons to become +2, or could lose 3 electrons to become charged with +3. The last option here is lead, which could lose 2 electrons or 4 electrons to get the charge +2 or +4 in these two different options. And the question is how to differentiate them from one another. Here, my friends, we only need to write the charge of the ion, here +2 and +1, and next to their names we use the Roman numbers. Some students don't know the Roman numbers, so that I have written them here. Number 1 here, number 2, 3, 4, 5, 6, 7, 8, 9 till 10. So that, my friends, here we have, for example, copper 1 and copper 2 plus 2. We have here iron 2 and iron 3. Sorry, iron 3 this way. And we have lead 2 and we have lead 4. So again, some atoms are confusing when they become ions. For example, copper could lose 1 or 2 electrons to get either +1 or +2. Iron has also 2 options. The first one is to lose 2 electrons to become +2, or lose 3 electrons to become +3. And lead, which could lose 2 or 4 electrons to have these 2 or 4 charged. And we said that if we want to answer this question, how to differentiate them from one another, it's important to memorize the Roman numbers, which will be used to refer to the number of electrons the atom has lost to become an ion. Finally, my friends, I would like to give final note, which is, finally here we have 2 types of ions. I'm talking about cations now. We have regular ions. Those regular ions are the ions belong to groups 1A, 2A, 3A. Always elements of group 1A will be positively charged with 1, like sodium, potassium, rubidium, cesium, francium, while the elements of group 2A will always get the charge +2, like beryllium, magnesium, calcium, strontium, barium. And finally, group 3A, which will always get the charge +3, like boron, aluminum, gallium, indium, and thallium. That's it, my friends, for today. I hope you enjoyed this class. If you don't understand a point in this video, please try to replay it again and try to play some Kahoot games which are related to monoatomic cations. In the next class, my friends, we are going to start talking about the monoatomic anions, and we are going to see why some anions get the charge -1, others get -2, the others get -3, and so on. Thank you again, my friends. I hope you enjoyed this class, and see you again. Goodbye.